Hi there, in this video I'm going to go through the concept of parallel and perpendicular lines. So if two lines have gradients m1 and m2, then if m1 equals m2 the lines are parallel, and if m1 times m2 is equal to -1 then the lines are perpendicular. So in other words, if the product of their gradients equate to -1, you have perpendicular lines. So let's use these concepts in order to help us solve the following examples. So in example number 1, calculate the equation of a line which is perpendicular to 2y is equal to x minus 3 and which passes through the point -2, 9. So let's have a go at this problem. So back to the paper and pen. The line that we're calculating is perpendicular to the line 2y is equal to x minus 3, and our line passes through -2 and 9. Okay, so first of all, I would say in step number 1, calculate the gradient of the line in question, because the line that we're calculating is perpendicular to this line. So we have the line with equation 2y equals x minus 3, and remember in the previous video, if we can rearrange this equation and rearrange it into standard form, so if we can make this equation as y equals mx plus c, the coefficient of x will give us the gradient of this line. So let's follow through the calculation. So let me rearrange this equation in the form mx plus c. So if I divide both sides by 2, I'm going to have y is equal to half x minus 3 over 2. So by comparison with the standard form equation of a straight line, the coefficient of x will give us the gradient of this line. So if I take a red pen, the coefficient of x is half. So the gradient of this line I'm going to call m1. m1, the gradient of the line, is half. Now in step number 2, the line that we're calculating is perpendicular to this line. So remember, going back to the screenshot, if two lines are perpendicular, m1 times m2 is equal to -1. Okay, so if we go back to the paper and pen, m1 is the gradient of the line in question, and the gradient of the line that we're going to calculate, I'm going to call that m2. So to work out m2, remember, we're going to use the result m1 times m2 is equal to -1, since our line is perpendicular to the line in question. m1 I've named as half, so it's half times m2, that is -1. So if I rearrange, m2 then is -2. So remember the idea of m2. m2 is the gradient of the line that we're going to calculate. So that completes step 2. Let's move to the final step, step number 3. So if you go back to the screenshot, we need to work out the equation of the line which is perpendicular to this line given, but it passes through -2 and 9. So if we go back to the paper and pen, so -2 and 9 is going to be our x1 and y1. So x1 and y1 is -2 and 9. The gradient of the line that we're going to calculate, m, is the value of m2, which is -2. And if you watch the previous video, so remember there's a formula to work out the equation of the line given m and given the point where the line passes through, and the formula is y minus y1, that is m into x minus x1. Okay, so let's substitute in the data. We're going to have y minus y1 is 9, that is equal to m, which is -2, into x minus, and x1 is -2. So if I expand brackets, I have y minus 9 on the left hand side, -2 times x is -2x, -2 into minus of a -2 is -4, And if I therefore take the minus 9 to the opposite side, we're going to have y is equal to minus 2x plus 5. So minus 4 plus the 9 when moved to the opposite side is plus 5. So this should be the solution to this example, example number 1. So example number 2 reads, calculate the equation of a line which is perpendicular to 3y plus 6x, and that is equal to 7, and it passes through the point 1 and 6. So let's see how this example is done. So back to the paper and pen. So the line that we're calculating is perpendicular to this line, 3y plus 6x equals 7, and the line that we're calculating passes through the point 1, 6. So remember the idea of step number 1. Step number 1, if I go back to the previous example, is to rearrange the line given in standard form, and the coefficient of x will be the gradient of the line given. So back to example number 2. So we have 3y plus 6x, that is equal to 7. So if I take the 6x to the opposite side, we're going to have 3y, that is minus 6x plus 7. And if I divide both sides by 3, I'm going to have y is equal to minus 6 over 3 is minus 2, so minus 2x plus 7 over 3. So this is the line in standard form. So this is the line in the form y equals mx plus c. And remember the idea, the coefficient of x in that equation is the gradient of that line. So I'm going to call the gradient m1. So m1 is the gradient of the line given, that being minus 2. So this takes us to step number 2. So remember in step number 2, so if we go back to the screenshot first of all, so we need the equation of the line which is perpendicular to this line. So if we go back to the paper and pen, so remember when two lines are perpendicular, m1 times m2 is equal to minus 1. So m1 we worked out, m1 is the gradient of the line in question. Let's use that result and calculate m2. So let's use the result, m1 times m2 is minus 1, m1 is minus 2. So if I substitute in, I'll get m2 minus 2 rather times m2, that is minus 1. So m2, the gradient of our line, is minus 1 over minus 2, which is 1 over 2. So this takes us to the final step, step number 3. So our line passes through the point 1, 6. So the passing point is x1 and y1. So when it comes to the formula for the equation of the line. So if we go back to the paper and pen, so let's gather the data. So our x1, y1 is 1 and 6. M is the value of m2 being half. So remember the formula to work out the equation of the line given m and given the passing point. It's y minus y1, that is m, open a bracket, x minus x1. And if I substitute the data, so I'll get y minus y1 is 6, that is equal to m, which is half, open a bracket, x minus and x1 is 1. Now if I open up the brackets, we're going to have y minus 6, that is equal to half times x is half x, half times minus 1 is minus half. And if I finally take the minus 6 to the opposite side, we're going to have y is equal to half x, and minus half plus 6 is plus 11 over 2. So that should be the answer to example number 2. Okay? So we have one more example, so back to the screenshot. So example number 3, so we need to calculate the equation of the line which is parallel to. So it's parallel to the line 2y, that is equal to x minus 3, and it passes through the point 4, 1. So our line is parallel to this line. So let's work out the gradient of the line given. So in step number 1, we have the line 2y, and that is x minus 3. So let's rearrange this in standard form. So if I divide both sides by 2, I'll get y is equal to half x minus 3 over 2. So now let's make the comparison with y equals mx plus c. And remember the idea, the coefficient of x in this equation is the gradient of the given line. So I'm going to call that gradient m1. m1 is half. So this takes us nicely to step number 2. Now if we go back to the question, so the equation of the line that we're going to calculate is parallel to this line. So remember the condition for parallel, if two lines are parallel, m1 is equal to m2. So back to the paper and pen. So m2 is equal to m1 as these lines are parallel, and the value of m1 from step 1 is half. So m2, the gradient of the line that we're calculating, is half as well. This takes us to the last step, step number 3. So if we go back to the question, so the line that we're calculating passes through the point 4, 1, and we have the gradient. So we're ready to work out the equation of this line. So back to the paper and pen. So let's gather the data. So x1 and y1 is 4, 1. M is the value of m2, which is half. So we're ready to work out the equation of the line. So remember the formula, y minus y1, that is m into x minus x1. So if I substitute the data, we'll have y minus y1 is 1. That is equal to m, which is half, into x minus, and x1 is 4. So if I expand the brackets, I'll have y minus 1 on the left. Half times x is half x. Half times minus 4 is minus 2. And if I take the minus 1 to the opposite side, y then is half x minus 2 plus 1 is minus 1. So this should be the solution to example 3. So that completes this example, and that sadly ends this video. So I hope you found this video helpful. I hope you enjoyed the video. If you did enjoy the video, a like will be very much appreciated. Do plenty of practice related problems, and I hope to see you again. Thank you.